All right, 12.3, we're still continuing to discuss circles. We're going to talk about some other kind of angles inside circles. So we have inscribed angles. So an inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. So, and then we have an intercepted arc. So an intercepted arc is an arc with endpoints on the sides of the inscribed angle and its other points in the interior of the angle. Okay. So an inscribed angle, if you notice here with this angle right here, this angle ABC, the vertex is on the circle and the sides are chords of the circle. And so then the intercepted arc is an arc with endpoints on the sides of the inscribed angle. So this right here, AC, is my intercepted arc. All right, we have an inscribed angle theorem. So the measure of an inscribed angle is half the measure of its intercepted arc. So again, I still use ABC here. The measure of angle ABC is equal to 1/2 the measure of arc AC. There are 3 different ways to prove this. One way to prove it is when the inscribed angle, when one of the sides of that inscribed angle goes through the center of the circle. So scenario 1 or case 1 is when the center is on a side of the angle. This is proven in the textbook on page 781. The second scenario is when you have the inscribed angle, but the center is inside the angle. So this second scenario, or case 2, the center is inside the angle. This one is homework number 26. The third way to prove it, so here's that center again. The angle is outside the center, or the center is outside the angle, I should say. This one is number 27, but it's not an assigned problem. But basically, you explore, to prove this theorem, each of these 3 different scenarios are looked at, but in each of these 3 different scenarios, it's always proven that the inscribed angle is always half of the intercepted arc. One thing I just want to make sure that we distinguish here, remember we have central angles, and with those central angles, so this is, I'll just call it MOP. So the measure of angle MOP is equal to the measure of arc MP. So in these cases, whatever that central angle is, that's the same measure here. So if this is 60 degrees, then that arc is also 60 degrees, okay? What we're talking about today is inscribed angles. And the inscribed angle is only half of this arc. So if this angle down here is 60, then this arc is 120 because it's only the inscribed angle is half of it. So in this scenario, the central angle is equal to the arc. This one, the angle is half of it. You could also just think about it that the arc is double the angle. So in a problem like this, it says find the measure of angle A. Well, I mean, obviously it looks like it's 90, but this is an inscribed angle here. And the arc that it intercepts is half of a circle, which is 180. So the measure of angle A is just equal to 180 divided by 2, or half of that, so it's 90. All right, there's some corollaries here. So the first one says two inscribed angles that intercept the same arc are congruent. So here's one angle intercepting this arc. Here's another angle intercepting. So they're both intercepting this same arc right here. So that means that the angles, angle 1 and angle 2, are congruent to each other. An angle inscribed to this semicircle is a right angle, which is pretty much what we just saw up above. So if I know that this is half of my circle right here, if I inscribe an angle right there, that has to be 90 degrees. And then it says the opposite angles of a quadrilateral inscribed in a circle are supplementary. So again, if I have this quadrilateral inside here, what it's saying here is that 1 and 2, as an example, if I add them up, they should equal 180. Or 3 and 4, if I add them up, they should equal 180. So it would be a good time, you could pause the video and see if you can get these last two, and when you're ready, unpause them and I'll show you the answers. All right, this one is using the corollary number 1, because if you notice here, they're intercepting that same arc right there. So the measure of angle 2 is just equal to 38. This one right here, 3 and 1 both open up to that a semicircle. So those are both 90. There's probably a couple ways you could find 4 and 2. If I just open up 4 though, like this, if you notice here, if you kind of ignore everything else, so here's the arc that 4 intercepts, and these two here add up to 140. So the measure of angle 4 is just half of 140, which gives me 70. So if 4 is 70, 2 and 4 have to add up to 180, so then that would make 2 110. All right, and then we have this third kind of angle here. I guess we could call it a tangent chord angle. So this one says the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So in this one right here, here's a chord, here's the tangent. So the measure of angle BAC is equal to half the measure of arc BA. So it's just half of this arc right here that it intercepts. So the next one, it says find the values of x and y. Again, you kind of should be able to look at it and kind of figure it out on your own without my help. But so you could pause the video and try it on your own. When you're ready, unpause it. Okay, so this one right here is clearly 90 because this angle opens up to the semicircle. This is 35. If you notice, I have a triangle right here, so just use what we know about triangles, remember? So all three of those angles have to add up to 180. So 180 minus the 90 minus the 35 is going to give me 55. To find x, so x has to be, so if I outline the sides of angle X, it intercepts this arc right here. So I want to figure out what that arc is right there. I know that this angle right here, this 35, also intercepts that arc. I remember this angle is half of this arc out here. So that would make that arc right there 70 degrees because it's double the angle. But this one is also half of the arc that it intercepts. So X is half of 70, so it also ends up just being 35 degrees. All right. We have two problems here we're going to look at, 11 and 24. So the 11 is a fun one here with a quadrilateral. So I will, I guess I'll redraw. I'll try to redraw it, I think. I'm not going to do a great job at it, but I'm trying. All right, this is 96. This is 100. So C and D are both opposite those angles. So C and 96 should just add up to 180. So do 180 minus 96 to get C. So we get 84. These two would add up to 180. So 180 plus, 100 plus 80 is going to give me the 180. Then it tells me I want to find A, which is right here, and B, which is right here. So there's a couple ways you could do this one. Again, I always just try to figure out what opens up to these ones. So this right here, so if I double C, sorry, this got a little confusing here. If I double C, so C was 84. If I double that, so B and A together are going to be 168. So right now that's not really going to help me though. What about if I look this other direction? So from this other direction, they also tell me that this part right here is 99. So if I open up that 100, so that 100, if I double that, this whole piece right here should be 200. If I know this piece is 99, that would make A 101. But then I also just learned that when I doubled C, this is supposed to be 168. So then that makes B 168 minus 101. Oops. So that makes B 67. All right, so for that one, again, this was number 11. I've got A is 101, B is 67, C is 84, and then D is 80. All right, and then the other one I was going to look at is 24. So for 24, so you notice here that we have a central angle. So remember I told you that that arc out there from that central angle is also 44. But A, way down there, is half of the 44. So A is 22. So this arc right here is 44. This arc here is 160. So whatever's left over is C. So around a whole circle, it's 360. So 360 minus the 44 minus the 160 would be C. And then to find B, so B is one of those tangent chord angles. It's going to be half of C. So I would take half of 156, and I'm going to get 78. So again, that was number 24. So I've got A is 22, B is 78, and C is 156. All right, that's it for this one.